Okay. So today I am going to start nonlinear spaces. Okay. So basically, so whenever I will called about anything called field, basically I will take suppose k. So in the whole course we will assume k equals to either r or complex numbers, the set of all complex numbers. So okay, so V is vector space over the field K. So first, the definition I will give that what is the norm on a vector space. Okay, norm. So what is this? Basically, uh, norm is a map from V to R positive. What is this R positive? X belongs to real number such that mod x greater equals to 0. So is a map such that this will follow some properties. First, norm of x greater equals to 0 and norm of x equals to 0 if and only if x equals to 0. Second, norm of alpha x equals to mod of alpha into norm of x. Third one is norm of x plus y less than equals to norm x plus norm y. Okay, this thing also, this last property is known as triangular inequality. Where okay, now, so first note that for this norm, we can induce a metric on V. Basically, what is the metric? By d of x comma y equals to norm of x minus y for x comma y belongs to V. Okay. Now, can anyone give me some example of a nonlinear space? Anyone? Can anyone? Can someone try? What can be? You know, right? You have worked on some kind of spaces. Can anyone try?
What is space?
What is?
Non-linear space?
No, this non-linear space. Non-linear space is a
No.
vector space with this norm, whatever I am defining. What I have started that V is a vector space.
Okay.
V is a vector space over a field K, right? So I am providing a norm, a mapping from V to R, which follows these three properties. Then together with the vector, if I take together the vector space and the norm, this is called a non-linear space. So can anyone give me an example of a non-linear space?
Yes,
Have you seen this kind of property anywhere? Yes.
Yes, we can first assume a inner product, then can define a norm that will be norm space.
No. I'm not going to the inner product at this moment. Okay. Can you see this? Can you see norm in anywhere? Some known number system?
Euclidean norm.
Can we
Yes.
take real numbers Euclidean?
Yes. Exactly. This is
Yes.
the first nonlinear space we have worked, but we actually don't know this particular name. The first example is okay. First example is R with the norm, basically norm of x. What is the basically mod of x, right? Or Rn for a x vector xn, we define the norm x1 square plus x2 square plus xn square, right? Okay. Please try to check whether these things uh, follow the three properties or not. Okay. Right? Did you get my point? Okay. Next. Okay. Now. No. No. Okay. I am used to going to use some terminology. First, this. Suppose V are non-linear space. So, if we say xn a sequence converges to x, this means limit n tends to infinity, norm of xn minus x tends to 0 or equals to 0 basically. Okay. Okay. Yeah. Okay. Try to do this, that
Sir, sir, I think it is
Yes.
a special case of convergence. It is L1 convergence, I guess.
No, no, no. It is an arbitrary non-linear space. No L1 convergence. I haven't defined L1 norm yet. Okay. This is an arbitrary norm. It is basically okay. Let me clear. I have given you a vector space with a norm. Norm is this. Yes. Hello.
Screen is not being so now.
Okay. Wait a minute. Is it visible? Is it visible
Yes.
now?
Yes, sir.
Okay.
Yes.
Okay. So I am not talking about any L1 now. Whenever I say V comma some bars is a non-linear space, that means V is a vector space, and by the norm I mean these properties, these three properties. That thing is following these three properties. Did you get my point?
Yes, yes.
Okay. Now you can have a confusion. Okay, let me try to explain you. Okay, so let me try to explain you in this way. Suppose, okay, tell me one thing. Uh, tell me one thing. Whenever, okay, if I say, suppose xn is a sequence of real number. Okay, you have studied real sequence. Hello, hello.
Yes, sir.
Yes.
You have studied the real sequence. So if I say this is suppose limit n tends to infinity, xn equals to x. Then we say that the sequence converges to x, right? It is the definition of sequence of convergence of sequence in real number. We say it, right?
Yes.
So, in other words, we can also write in this way, right? Limit n tends to infinity, mod of xn minus x equals to 0. We can also say this, right?
Yes.
So it is the, you can say this definition is basically the equivalent condition. I mean, I know the framework how the sequence convergence are. So we are trying to more generalize this on any non-linear space. So that's why we are giving this definition. We say xn is a sequence in V converges to x. That's mean limit n tends to infinity, norm of xn minus x is 0. Is it clear?
Here, sir.
L1 norm is a special kind of norm. We will discuss what is the L1 norm. Okay, now
দাদা বলছি এটাকে তো আমরা এমনি মেট্রিক স্পেসে কনভার্জেন্স হিসেবেও তো ভাবতে পারি, মানে এক্সেনটা
yes,
ভি এর
yes,
মধ্যে যেহেতু
yes, yes,
দুটো একটা ইনডিউস
yes, yes. We can think about it. By this norm, we are getting a metric. So actually, we are talking about what is the sense of convergence in metric space. That's not a different thing. They all are similar. By the mean norm of x in whatever I have defined previously, that d of x comma y equals to norm of x minus y. So whenever I am writing norm of x minus x, it will directly implies that it is d of xn comma x. Now you know the sense of convergence in metric space. So basically, we are doing the same thing. Okay. Okay. Now. So, and xn converges to x and converges to y. For alpha belongs to k, show that alpha xn plus yn converges to ax plus y. Okay, please try this
তো এটা
now.
আলফা এক্স প্লাস ওয়াই হতো মানে স্কেলারটা তো আলফা বললে তো
Scalar is alpha, yes.
মানে তাহলে তো ওটা আলফা এক্স প্লাস
Ha
ওয়াই
ha.
হতো
Yes, yes, yes. That's the thing. Okay. Is alpha. I was in hurry, so that's why I write here. So please try this. This exercise also this if xn
We can use
converges to
triangle
x,
inequality.
then okay. Wait a minute. Okay. You are going to use triangular inequality. Yeah, it will work. Okay. For the second one, can anyone try this? How second one will work?
Difference between norm xn and norm x is less equal to d of xn comma x equal to norm xn minus x and which tends to 0. So by sandwich theorem,
Okay, fair enough. Okay. Now, so Kn, which is what? x1, x2, xn belongs to such that xi belongs to k for all I equals to 1 to n is a vector space over k. It is known to all. We have done this on linear algebra course. Okay. Now I am going to define a norm. So first, this thing. Of one norm is nothing but basically summation of xi this
Sir,
thing.
we can use triangular inequality to prove second bit.
Yes, it is actually the application of triangular inequality, of course.
Yes, so we don't have to define a specific norm.
Yes. Can you repeat again?
We don't have to specify a specific norm to prove this. We can use
No.
triangular.
It is not norm specific. Just any norm will do the work.
Yes.
Okay. Fair enough. Basically, you all have done some analysis on real number, right? So if you have any problem to understand what is the norm kind of things, so just think about the whatever you have done a real analysis. Okay. For the initial practice, it will help you. Then whenever you have done many problems, then we will figure out what is the norm stuff is. Okay, next. So this is called
L1.
one norm. Okay. Sometimes it is one norm basically. Okay. Then I am defining another thing. It is basically supremum of
Maximum.
I equals to 1 to n. Okay. Okay. Now. So now. Also now, okay. Now I am giving some examples of nonlinear space basically. Another is suppose a comma b belongs to real number. So consider this space. What is this? It is nothing but if a comma b to r such that f is continuous.
Continuous.
Okay. I can define a norm of f for f belongs to CAB. This is the supremum of mod of fx such that x belongs to a comma b. Okay, I am asking one, tell me supremum of fx for x belongs to a comma b will exist. Can someone try? Please, someone say me. I need the answer. Why? Why this has a norm? I mean, the supremum mod of fa exists when x belongs to a comma b. Please try.
Because domain is bounded.
Okay. So, is it for the supreme for existence of supremum boundedness is the boundedness enough?
Therefore, function will be bounded also.
No. Think about it. You are almost there. Just one property of the DOM. Yes.
Function is continuous and domain is bounded. So supremum exists.
Okay. You are saying suppose domain is bounded and the function is continuous, then the image is also bounded, right? You want to say this?
Yes.
Okay. So let me do a trick. Okay. Suppose take if 0,1 to r by f of x equals to 1 by x. 0,1 open interval is bounded, f is continuous.
Domain is not closed here.
So what is it? What we are using here? The compactness of the domain, right?
Yes.
Continuous image of a compact set is compact, and any compact set on R is closed and bounded, right?
Yes.
Yes.
Okay. So we can describe the example to in more generalized way. Okay. Okay. So for the third example, we will take, let X be a compact Hausdorff space. To R such that F is continuous. Okay. So in this way, we also we can define here a norm. Also, it is denoted at F infinity. It is denoted by supremum. Okay, is it clear? Okay. Now, okay. Again, for the fourth example, I am going to take again this set. Now we define F1 in this way. It is also defined also a nonlinear space. Okay. Okay. Now. Okay. Okay. So now.
Sir, for function analysis for this course, which reference can we follow that can be fit for this to this course?
I will suggest you to go through Kumaresan, but not only theory part, also the also the problems, because Kumaresan is very student friendly book. But if you think, okay, I just go through all theories, and if you don't touch any problem, then it will be difficult, because function analysis requires to learn function analysis. It is required to go through many problems. Otherwise, you will not get the flavor whatever you have to do, because there are some tricks to solve up function analysis problems. So the process is, I will suggest you, if it is possible, to go through the Kumaresan book.
Sir,
Okay.
can you follow Conway or Rudin to accompany?
Oh yeah. If you want, you can. But if you frankly ask me,
In Kumaresan's book, actually there is not so standard.
no, I am saying to
Problem portion is
whoever whoever is learning functional for the first time. Rudin is not a book, right? To learn something for the first time, or the not, or not the actually not the Conway also. They are the very tough book to go through. In some sense, there are some notations. If you want to study Conway, then you have to do everything from the beginning, because Conway has some different notations also for Rudin. If you have studied functional previously, then you can do Rudin, Peterson, Conway, any standard book you want to do, you can do. Of course, you can do. But whoever are going to study function for the first time, I will highly recommend it. Please go to Kumaresan, because you can understand this book by yourself. And Kumaresan sir provides very good exercises in his books, so you guys should go through. Okay. Okay. Now,
Sir, is its PDF available online? I have searched before, but there it's not.
no, Kumaresan book, I think PDF is not available at online. You have to buy that book. We will get on online platforms. Yeah. Okay, so now we are going to study next thing, inner product space. Okay, okay, okay. VBA, let VBA vector space over key by inner product we define map by the following properties. First, okay. First at all, second at all, third, and fourth. Okay. Exercise. First, through this. Okay, wait a minute. Okay, exercise. So this. Show this. This three. Try it now by
Sir,
using the definition of inner product. Wait, wait. Let others also try. Don't be in hurry. Other one, please try it. Just three exercises. Please try this. Inner product is given on a vector space, the four properties. Use that four properties to show this three property. Please try. Okay, please try this. Has anyone tried this?
Yes.
Yes. Say, how have you done this? First one.
First one, change the order of YZ to first place. Then for me conjugate, then use the
Okay.
linearity.
I got it. I got it. Whatever you have used this x comma y plus z equals to conjugate of y plus z comma x, right?
Yes.
Then you break it, conjugate with breakup, and then you will get again. You use the
Conjugate.
third property. You will get the whatever you are looking for, right? Okay.
Yes.
Okay. What about the second one?
Second one also same.
Okay.
Just change the order.
Yes. Yes.
Take
Yes.
the
Yes. Acha. What about now the third one?
third one, just put y is equal to x.
Okay.
That's
Now by fourth property, right?
yes.
Okay. Very good. Okay. Now we are going to see an inequality, very useful inequality. Okay. Put the inequality in your mind. It's a very useful inequality. Okay, so Cauchy-Schwarz inequality. This inequality known as Cauchy-Schwarz inequality. What is it saying? If V comma inner product is a inner product space, then mod of norm of y. Okay, let's look on the proof. Okay. Okay. So if first case, if x equals to 0, then it is this then star is true. Okay. Okay. in case x not equals to 0. So so we may define z defined to be y minus okay. Now first calculate this term. What is this? It is basically inner product of y minus what is this? It is nothing but what is this? It is x comma y bar into x comma y so is this part clear? Okay. Okay. Now which implies okay. So what is y? What is y? Y is basically this. So y is basically inner product of z comma okay, sorry, my mistake. Wait a minute. Okay, okay. So what about z comma x? Okay, so z comma x means basically y comma sorry, y minus so it is basically what 0. So whatever we are getting that first we have got that z comma y equals to we can write what is y? Y is z plus So whatever, so we can write this hence. So we will get this. Is it clear? Is it clear to everyone? Okay. So now we define norm x, we define a norm on V by this inner product. V by or x belongs to V, x is defined to be root over of x comma x. Okay. Okay. Can someone try, if we are going to define norm by this inner product? I mean, I am defining such root over of x comma x. Prove that this will become a norm. Can anyone say why it will become a norm? That's by root over of inner product of x comma x. This will going to satisfy the previous three properties, whatever I have write on nonlinear space. Can anyone try?
Since inner product of x between x is non-negative for any x belonging to V, so the square root of this is defined. So this is a well-defined function. Now the square root, so the square root is non-negative for any x belonging to V, and this equal to 0 if and only if inner product between x comma x equal to 0 if and only if x equal to theta V, since this is an inner product on V.
Okay.
Now norm of alpha x equal to inner square root of inner product of alpha x comma alpha x equal to alpha, I mean square root within alpha but inner product of x comma x. So equal to mod equal to square root of mod alpha square into inner product of x comma x. So equal to mod alpha times square root of x comma x equal to mod alpha times norm x. And for triangle inequality,
I was going to say that. Please prove the triangular inequality. But other parts are trivial to explain. Very trivial. Try this part. How you are going to show?
norm of x plus y whole square equal to inner product between x plus y comma x plus y.
Okay, okay,
So,
stop it. Others try this. Let's other also try this. Some of you, rather than Saurabh, please try. Other than Saurabh, please someone try to explain the triangle inequality part. Take time and just try. Hint is use the Cauchy, you have to use Cauchy-Schwarz inequality in some sense. Okay. So please try.
Norm of x plus y is root over inner product of x plus y comma x plus y. That will be converted into norm x square plus norm y square plus 2 times the real part of inner product of x comma y. The real part of inner product of x for y is greater than is less than equal to the product of two norms by Cauchy square inequality, then it will be a perfect square. Then if you will take a square root, then it will come out to be mod x and norm x plus norm y.
Okay, can you repeat that? I would like to write this. Please repeat whatever you are saying. Whatever you take first, tell me. I will write the. Please repeat the proof again.
Inner product of x plus y comma x plus y is equal to norm x square plus norm y square plus 2 times real part of
How the two times real part of this thing is coming?
Inner product of x comma y plus inner product of y comma x. Y comma x is the conjugate of x comma y. Z plus z bar is equal to 2 times the real part of z.
Okay. Next.
Here, then inner product of xy is less than equal to the product of norms by Cauchy square.
Wait a minute. So I'm not getting the point. What is the third line?
Third line inner real part of inner product of xy is less than equal to modulus of z. Real part of z is less than modulus of z.
So you are saying, you are trying to tell this, right?
Yes.
Right?
Yes.
Okay, then
Real
you are then Cauchy-Schwarz inequality. Also, this implies okay. 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 Very good. Okay. Now I will like to do some examples. Can someone Suppose K is basically R or C. Okay. So what can any is there any guess what can be the inner product on Kn? What can be inner product? Any guess? Any guess? Please try.
Mm. For inner product x1 into xi summation of xi into yi conjugate.
Summation into xi.
Into yi conjugate.
Yes. Very good. Okay. Okay. Give me a minute. Okay. Okay. Second example is basically L2. What is this? It is basically defined to be Xn is a sequence in K such that summation mod of Xn square is less than infinity. Okay. So on the okay. This defines the inner product. Okay. I have a question. So my question is, so basically, I am defining inner product of two sequence in this way. By the basically, I am taking the summation of the product of conjugates kind of stuff. So can anyone say why this sum will converge? Whether converge or not. Otherwise, if it is not convergent, there is no sense of talking about the inner product space or whatever. Okay, so can anyone say whether this thing is converge or diverge? Hello? Can anyone say whether this will converge or not? Hello? Hello? Am I audible?
Yes, this will converge because xn and yn both belongs to L2. We can use to
So,
there
we
we
can
can
use
use the uh, test of a series convergence London real numbers.
which test? Which test?
Ratio test will be good.
Okay, ratio test.
Yes.
How will you do the ratio test? Please tell me.
Xn plus 1 into in plus 1 conjugate by xn into in conjugate. Both individually less than 1. In product will be
Why?
less than
Why it will be individually less than 1?
because they're because sorry they're individually convergent.
So that's what I am asking, na? That's what I am asking. Why? Can anyone prove this? They are not individually not convergent. Their square is absolutely their squares are individually convergent. They are not. Okay.
Okay.
Can anyone like to try it? Please try. This is a basic reanalysis. You guys should do this. Just the manipulation. Just they use the definition. What is the convergence? What is the meaning of the convergence of the series?
Sir, if since summation xn square, since summation mod xn square is convergent, so limit mod xn square is 0 as n tends to infinity. So this implies that limit xn square is 0 as n tends to infinity, and this implies limit xn is 0.
Okay. So
And this implies that there exists a natural number k such that for every n greater or equal to k, mod xn less than 1. And this
less
implies
than
for every n, and this implies that for every n greater or equal to k, mod xn square is less than mod xn. And now
then what?
from
Next. This will not work, believe me.
We can use a Holder inequality to convert it to its square.
But okay, Holder inequality is one way to prove this. But the point is, we haven't studied anything. If you are going to use Holder inequality, then you have to just prove it.
Cauchy square is the Holder inequality special case. Can use
But
Cauchy square.
we have done the Cauchy squares for the finite dimensional case. We haven't studied Cauchy squares in infinite dimensional case. Okay.
Yes.
Okay. Let me show you the trick.
Sir,
So,
I think
what we are going to
can
do?
can I say
Yes, you say.
mod xn into yn bar equal to mod xn times mod yn. And this is equal to 2 times mod xn into mod yn. and this
Okay.
list equal to mod xn এর whole square plus mod yn plus whole square of mod yn
Okay.
by apply at the AMGM inequality, and then since x and y and both are in L2 space, so and from comparison test, so this CLG absolutely convergent, so and hence convergent.
We'll see. No, you are okay. So you are using this fact that model. You are using this fact that. Oh, wait a minute, wait a minute. Yeah, it will work. So whatever he is saying this mod of xn yn bar less than equals to by 2, right?
Yes.
Is it?
Hmm. Yeah.
And
It will work.
summation of finally when convergent series is convergent.
Yes, it is.
And hence-
Then it is fine. Then it is okay. Everyone get this proof?
Yes.
Has everyone get this proof? Yes or no?
Yes.
Okay. Okay then. Okay. Give me a moment. Okay. So we are let's. Okay, I am going to stop this class now. So we will meet at next Sunday. Okay. Good night, everyone.
Sir, can the handouts be